The other side of that we found on this too is not only having enough in there, but also keeping it in the pore space. So if you put enough in there to begin with and it doesn't stay in there, it's not going to do you much good. And so we found that if some of the polymers would elute or flow out of the system, the conductivity would increase. And one of the factors that influenced the amount of elution was in most clays, we're always thinking about cations, sodium, potassium, but the anions. We have some, for example, co-combustion product leachate, which are very chloride rich, others which are very sulfate rich, right? Depending on what kind of plant they come from. The anion ratio, as we call it, of chloride to sulfate is really important. So some very sulfate rich solutions, they create a polymer structure that stays in the bentonite, very impervious. Others, very chloride rich, can allow the polymer to elute or flow out and become very permeable as well. And it really is driven by how the polymer shape is. We have solutions that allow the polymer to, you imagine a polymer is just a long molecule. If it can extend itself and kind of be a big extended gel in the pore space, it tends to get stuck, right? If it balls up into a little particle, it just flows through the pores. And so it really has to do with whether it's coiled or it's extended, and the chloride solutions tend to promote coiling. And so the point is the chemistry is really important. Do we get something that looks like the top, that's for a chloride, that's a hydrogel in a chloride solution, or in the bottom in a sulfate solution? One creates this great net which fills the pores. The other creates these just little blobs that flow right through.